afternoon, and thank you all for standing by. For the duration of today's conference, all participants' lines are on a listen-only mode. Today's conference is being recorded. If you have any objections, you may disconnect at this time. It is my pleasure to turn the call over to your host for today, Ms. Lacey Lofton. Thank you, ma'am. You may begin.
Good morning or afternoon, everyone, and thank you so much for joining us today for a Census Academy webinar. Today we have a wonderful presenter joining us. His name is Jim Castaneri. He was telling me earlier that he has been with the Census Bureau now for 35 years, so he is a wealth of knowledge, and he is the geographic coordinator for the Denver region. So he covers 12 states, handles all of the geographic operations for basically the middle of the country. So today he's going to walk us through statistical geographies. This is really great timing, especially with the pending 2020 releases. He's going to walk through not only what statistical geographies are, but some of the practical uses and how things have changed over time. A couple housekeeping things. If you have any questions, please chat them. We're not going to do a live voice Q&A. But if you have any questions, please include them in the chat. We will bring those questions up during the presentation if that seems like the right timing, or at the very end, we'll cover any questions that we didn't get to while we were going through this PowerPoint and then the live demo at the end. You don't have to frantically take notes. We will have a copy of this presentation as well as a recording on Census Academy, and I will send that link out in the chat later on. So those resources will be available to you later, probably next week. We'll have the recording and the PowerPoint available. At the very end, we will have a survey. Please take a few minutes to fill it out. Let us know how we did, if there's anything you'd like us to focus more or less on in the future. We really do take all that feedback very seriously. So please let us know what we could do better to serve you. And then without further ado, Jim, are you there?
I am. Can you hear me okay?
I can hear you great. Okay, Jim, I'm going to turn it over to you.
Thanks, Lacey. Thanks, everybody. Good day, all. I hope most of you are in and out of the cold. The weather has been a story lately, and I know for Lacey herself, it's been a challenge. She didn't mention it, but she just got her power back on there in Texas. I'm in Denver, so hopefully the power here will stay on for us. Let's all cross our fingers.
Yeah, fingers crossed.
Welcome to our discussion about statistical geography. Let me take a moment to kind of put this topic in context for us. Through my experience working at Census and with others who are primarily concerned about the application of our data in a spatial frame, whether that's GIS or another type of application that looks at the distributions of our data, a key requirement for understanding the use of statistical data is really a basic understanding of census geography. And so let's talk a little bit about that. And I'm going to see if I can't manage two screens at once and make sure I advance to the proper slide.
Very well done.
Thank you. So in our overview of census geography, there are two main types of census geography we're going to discuss today, and they are legal or administrative and statistical geography. Actually, we're going to focus on statistical, but we needed to mention the legal aspect. The little diagram there to the right is a little bit dated these days, but it kind of illustrates for us that hierarchy of census geography. So what are the basics of our legal or administrative geography? Well, first of all, they all have a highest elected official. These can be in the form of a city mayor, a county judge, or a group of county commissioners. Boundaries for these legal geographies can change at the will of a governing body. And these entities can have new incorporations based on a local election or a regional statute. So what are some examples of legal or administrative geography? Of course, states, American Indian reservations, counties, places, and these are incorporated places, congressional districts, school districts, and voting districts. These are all examples of legal or administrative geography. Let's focus our attention now on statistical geographies. For statistical geography, and we're going to see some examples of them in a moment, there are no gaps or overlaps. These are boundaries that are created by the Census Bureau and maintained by the Census Bureau for use by the public. They're created for statistical purposes, and we're going to see have some discussion about that. Whereas political boundaries are used for elections and reapportionment and things, statistical geographies have their application in science, research, and planning. A point to mention is that the U.S. Census Bureau is the geographic data steward for the federal government. Not only are we the data steward for political geographies, but we are also the data steward for these statistical geographies. So let's talk about some examples of statistical geography. Once again, at the top, we find states. Of course, the country itself is the primary entity, but we tend not to talk too much about that when we're looking at an analysis of our data within our country. But at the top sits states. Below the states are counties, and you'll notice that there's a very close match to political geographies. But the third bullet is where the statistical geographies deviate from that political hierarchy. We have census tracts. Below that are census block groups. And at the smallest level of geography is the census block. Now, there are two more bullets here on the list that we're going to talk about. They are the census designated places, or CDPs, and census county divisions. And we'll talk about each of these as we go through our presentation.
And I just want to jump in here. Obviously, when a lot of us think about where we live, we think of, political, so either legal or administrative areas, so the city you live in, the neighborhood you live in. But what's really nice about statistical geographies, and one of the main reasons that the Census Bureau, developed them, maintained them, and continues to publish so much data for these statistical geographies is we can track changes over time. For a lot of cities and places, the boundaries are constantly changing. Same for voting districts or legislative districts. When you compare something 10 years ago, if you say the city of Houston is not the same 10 years ago as it is now. So these statistical geographies really give you comparability over time, and because we can control them, you can really do deeper analysis either over time or even just looking at change within a certain area.
So we would be remiss if we did not mention the variety of tribal statistical geographies. And while today's focus is not on tribal statistical geographies, they are a separate presentation for later in the year, it's worth mentioning that they do exist. There are tribal census tracts, tribal block groups, and these data are published along with the standard census tracts and standard block groups. On tribal lands, there are census-designated places. They are not differentiated from standard CDPs. But then we have, across the country, tribal-designated statistical areas, or TDSAs. There are state-designated tribal statistical areas. That's a mouthful. Try saying that quickly. Or SDTSAs. We also have Oklahoma tribal statistical areas. And then there are statistical tribal subdivisions. So these are very similar to the statistical geographies we're going to discuss today, but their focus are for federally recognized tribes with federally recognized land bases. Some of them are for state-recognized tribes without a land base, and as you can imagine, there's a whole discussion around these geographies. I mentioned before, we won't be talking about it today, but we will cover this issue in a later presentation. So there are a couple of statistical geographies in our standard hierarchy that we need to talk about first, because Lacey and I have done this presentation many times over the past several years, and there are a couple of these geographies that don't quite fit in with the standard hierarchy. And one of those is the census-designated place. And I wondered if my colleague Lacey would take a moment to talk about these.
I'm very happy to. Jim doesn't love these because they don't fit into these perfect nesting blocks. But a census-designated place, there are many places in the country where they have a real sense of self. People will say they live in a place. It's kind of the equivalent of a city, but it's not actually incorporated. There's not actually a mayor of that area. So what we did at the Census Bureau was draw boundaries for these places, even though they aren't actually incorporated. They're not incorporated places, but drew boundaries with help from local officials of where people conceive those boundaries to be. So there are a couple really prominent examples. One of the biggest things here I should mention is a census-designated place cannot overlap or be part of a real incorporated place. So they are completely separate. For those of us in Texas, the Woodlands outside of Houston is a great example of a census-designated place. It has a real sense of place and purpose, and we publish data for it just like we do for any other incorporated city, but it is not actually incorporated. It doesn't have a mayor, so it is a census-designated place, not a place. And I believe on the next slide we have a couple of examples. Here we go. Here's another example. So Notre Dame, where the university is, there's not an actual incorporated place there, but it definitely has a sense of self. So we created a census-designated place so that we can produce data for it. So you can look over time how things change, or you just even understand in the moment who's living there and what the population is.
And Lacey, I think CCDs are also your favorite. Would you mind talking about those as well?
They are my favorite. Census county divisions are another thing that we're going to focus mostly on these nesting geographies going forward, but this is one more we should mention. We work with local officials throughout the country to help create these, and these are just as basic as they sound. So they are literally just counties or county equivalents divided up, and then we name them and we publish data for those divisions of the county. In some places, it fills a gap where we're not publishing, where data is needed for an area and it doesn't really fall within one of these other geographical boundaries. So I actually love census county divisions in that they are very flexible for local officials if they need data for an area and it doesn't fall into a different kind of geography. This is really a catch-all where you can make them. There's a lot of liberal application here. So that's census county division. And those are the two statistical geographies that don't really fit into this nesting hierarchy we're going to talk about going forward, but I did want to mention them. Jim, there is a question here in the chat, and it's roughly how many CDPs are there? Do you have any idea nationwide?
I don't.
Not to put you on the spot. There are a lot. I know in Texas we have hundreds. In Texas we have, I think, there's definitely hundreds and hundreds of them in Texas. Or hundreds of them in Texas. So nationwide, you're looking at a big number there.
Right. Travis County, for example, is divided into 4 CCDs. And CCDs are the statistical equivalent of minor civil divisions, and they don't exist much east of the Mississippi. They're primarily a Western phenomenon, and the idea was, hey, the West Coast has all these minor civil divisions for which there's great data. Why don't we have those? Well, they're political. CCDs are statistical entities. And the interest in the CCDs, I should point out, has faded somewhat. I know Lacey won't like me saying this. They faded somewhat because the Census Tract, when it was introduced nationwide in the 90s, really kind of drew some interest away from that sub-county statistical division, which is the Census County Division.
And that's absolutely right. I mean, these are larger. Now we're able to publish data at a much lower geography, which is much more applicable to most people's research or planning or development. So I don't disagree with you. I just still like Census County divisions.
And which is why we let her talk about them. She does a good job with it. Thanks, Lacey. So let's move on now, if we could, to Census Tracts. And really, if you're a geographer, some of us are, and you do GIS, some of us do, Census Tracts are kind of the meat and potatoes of the statistical geographies of the Census Bureau. There's so much to say about Census Tracts. We don't have enough time in the day, really, to talk about all of the vagaries of census tract definition and design. There could be a whole classroom discussion on these. We're going to touch as much as we can on these because there's quite a bit to know about them. And so the next several slides, we're going to talk about census tracts. Comparability is probably the number one concern with census tracts. Lacey, wouldn't you agree with that?
Yeah, absolutely. Comparability over time, specifically, that's one great application because we can track changes over time. I know you're gonna go into that later in the presentation, but also comparing a census tract to another census tract because they have about the same population. So they're supposed to have around 4,000 human beings in each census tract. So you can really compare. You're starting off with a baseline that is similar, which is a really big deal. If you're comparing, say, Houston, Texas, to a small town, like I live in Leander, Texas, it's hard to do that because the populations are just so vastly different. Census tracts really normalize that and give you a starting point where you can compare one census tract to another, and then you can also compare census tracts over time.
And Lacey said a key word there for me as a geographer. She said normalize it. And those of us who've done representation of really any kind of data, when you're not talking about a consistent piece of geography, you often have to normalize. For example, persons per square mile. If you simply represented two distinct populations in different areas and said there are 10 million people in Houston and 500,000 people in Leander, that doesn't really tell you much. So you normalize the data by unit area. Census tracts are designed in such a way that it's not necessarily important to normalize the data because of their criteria, their optimum of 4,000 people, the maximum of 8,000, and the minimum of 1,200. Now, every time I try to talk about this minimum criteria for tracts, I get a little bit confused. So once again, I'd ask Lacey to comment on that minimum for census tracts.
Yeah, so there are some census tracts in the country that have below that 1,200 population. There are many different reasons for this. One of the most common reasons is that every county or county equivalent in the country has to have at least one census tract, just by design. There has to be at least one census tract in every county or county equivalent. And there are actually a lot of counties in the country that don't have 1,200 people. So by default, there will be tracts below for that reason. We also have some special situations that I know Jim is going to talk about in one of his examples. But if there is a large area of land that is just not populated for whatever reason, we sometimes will carve that out and make it what's called a special use census tract. The reason we do that is so that we're not diluting basically the population density of the tracts surrounding it or around it. So that's another reason you might have a census tract with a very low population. Last but not least, in some situations, there is a mass migration out of an area. And so even if it started, and we're going to talk about this, but these census tracts, we redo them every 10 years, right before the decennial census. If there was a mass migration of people out of an area during that 10-year period, it is possible that the population and the estimates will fall below that 1,200 threshold. So we try to keep it above 1,200 because at 1,200 we can publish most ACS. The American Community Survey is our biggest survey and one of the most rich data products that we produce. At 1,200 people, we are able to produce most of the main data points from the American Community Survey. So that's why we have that minimum, but sometimes it does fall below that. If it is below that 1,200, we will still attempt to publish data. We just get into some situations where for making sure that we're not disclosing information about an individual or a household, we might have certain data points that we can't publish, and the lower, we get with the population of census tracts, the less data we can produce. So we try to stay above 1,200. Is that about right, Jim?
That is more than about right.
Okay.
Thanks, Lacey.
Yeah.
I appreciate that. We are going to talk more about tracts in detail as we move forward. I'd like to cover the next piece of geography real quick. Perhaps not real quick, but to put this into perspective, there is yet another subdivision of census tracts. These are block groups. Block groups, their main difference between block groups and tracts, well, first of all, they are smaller and they are a subunit of a tract. They nest within. But block groups, unlike census tracts, are not designed to be comparable from one decade to another. Whereas tracts, a primary tenet is that they are comparable through time, block groups are not. It's conceivable that a certain set of block groups in a single census tract have not changed across decades because the block groups are so well defined and the population within that tract has not changed much. But ultimately, block groups are not designed to be a permanent fixture like census tracts are.
Right. We actually have a couple of questions in the chat, so I was going to mention that as well. So sure. You're absolutely right. Over time, it is possible that the block group doesn't change, but we can't rely on that. But there were also several questions in the chat about do blocks change from decade to decade? And so I just wanted to jump in and say they do. Blocks are another geography that we completely start over with every decennial. So the blocks are not comparable at all decade to decade. They are just space and time. So you can use them for just what's happening on the ground now, but you can't compare them to decades before or decades later.
Exactly. Okay. So the criteria for block groups are obviously different because they are smaller. You can see the numbers there. We have housing unit count criteria as well as population. Once again, their criteria are based on a need to define what makes sense on the ground, so there isn't any comparability. The other important thing to mention about block groups, and I have to be careful when I say this because I have a statistician on the phone with me, is that they are the smallest area for which demographic data are available through the American Community Survey. Now, as geographers, and we're doing GIS work, we love to look at block groups and say, look at this fine granularity of data we can use and we can map. But that can be a problem. And I wonder, Lacey, before we move to this hierarchy discussion, if you could tell us why that might be a problem.
Sure. So we will attempt to publish American Community Survey data for the block group, and Jim's absolutely right. This is the lowest geography that we even attempt to publish ACS data. But there, again, because it's the smaller the population, the more that we are not able to publish so that we're not disclosing an individual or household. So we will attempt to publish data at this block group level, but there's less rich data available at the block group than Tract. Tract is really the one where we're able to publish a lot of information from the American Community Survey. So that's really your richest geography from a statistical standpoint. And now, is this the nesting part? This is my favorite.
It is.
All right.
This is the nesting part. Are you going to take the first one, Lacey?
Sure, I can, absolutely.
Okay.
As Jim mentioned, we've been doing these presentations for, I think you shortchanged us. We've been doing these for a really long time now. And we struggled for several years to figure out how to make this nesting of census tracts, census block groups, and blocks relevant and understandable to people who are, applying these geographies and applying the data that comes with them. So we made this kind of click-through chart so we can just show you how this actually happens on the ground. So it's not such an abstract thing with numbers and just a lot of statistical and geography talk. This is how it actually applies to your neighborhood or to your country, to your state, your county. As Jim mentioned, every single place in the country is covered by a census block and only one census block. So remember, wherever you're standing, everything is covered in the country, and it's only covered by one geography. So let's look at what that actually means in real life. So on this first one, as Jim mentioned, the USA is our starting point for all geographies. But if we want to go down a level, next we'll look at the state. So I believe in this example, we are looking at Texas. There we go. Maroon. I went to A&M, Gig'em. So here's a maroon state, Texas. So if we zoom in on this state, what we'll have is a code. So every single state in the country has a code, and it's the FIPS code. So Texas's number is 48. So if you are looking at a GeoID and it says 48, you know that you're looking at Texas and only Texas. If you go a level lower geographically, we can look at the county. So I believe this is Travis County. This is right in central Texas where Austin is. This is where I'm sitting right now, hoping the power stays on for the rest of this presentation. And every county has a 3-digit code. So if you see a GeoID, that is 48453. That means you're looking at data for Travis County, Texas. If you go down one more level to the census tract, which we're going to talk about really in depth here because this is our most applicable geography statistically, every census tract has a 6-digit code. This is in Travis County, so we're looking at tract 036000. If we go down one more level, we get to that block group level that we were just talking about. Every block group has a 1-digit code. There can only be 9 block groups per tract, so this is block group 1. And last but not least, we're going to go down to the block level. And this is something I'm going to mention here. Blocks seem like a really abstract thing when we get into some of the methodology and a lot of the long papers that we are able to write about something that's fairly simple. A block is just what you think of when you're walking the dog around the block, or as Jim pointed out in one presentation, and I gave him a very hard time for it, the milkman going around the block, the milkman. So just literally just the closest, the smallest polygon you can draw. So if you're walking around your neighborhood and you're turning right and you're turning right and turning right till you get back to your house, that's what a block is for census data. Each block has a 4-digit code. So if you're looking literally on the ground what this looks like, and this first example we did a more rural area, so you can see kind of the comparison. Jim's going to do an example in a moment of a more urban, densely populated area. But this code, and it looks long and cumbersome, but we're hoping to make this relatable, 484530600011006 is this piece of land. That code will tell you that you are looking at data or that these are the specific boundaries for that GeoID. And that will always be the code for that area. Again, we'll talk about how they change decade to decade, but you know for sure this is what you're looking at. There is no other piece of land in the country that has the same GeoID.
Perfect. You know, what's frustrating is that as a geographer, I always am amazed that a statistician does a better job explaining the geography than I do. So I'm going to take a stab at it.
No pressure. Thanks a lot.
No pressure. I'm going to take a stab at giving another example and going through the same hierarchy with a different piece of geography. So let's see how this looks. Starting at the country level once again. And we are going to go to Texas again. Many of you may realize that the decennial census for the Rocky Mountain region was managed out of the Dallas office. That office is still open, and I spent a lot of time down there over the last 5 years, so I got to know Texas quite well. As Lacey pointed out, here we have the state of Texas, and it has a FIPS code assigned of 48. Incidentally, Colorado, where I am currently residing, has a FIPS code of 08, and it's important to mention that in our data products, the FIPS codes, and actually they are NIST codes now, they are character and not numeric. So when you go to search for these codes in our data products, Colorado will appear with a state code of 08. And it's important to realize that those leading zeros have to be maintained in order for GIS to function well with the data and the geographies. All right, so here we have state code 48, Texas. We're going to zoom in to a different part of the state this time. This is Tarrant County, Texas, which is Fort Worth, and a wonderfully box-shaped county, just like Colorado. Makes me feel at home. In the yellow outlines are the census tracts within the county. There are quite a few because it's quite a populated area. If we highlight a single census tract right there in the middle, we find that it also has a 6-digit or 6-character code. In this case, it's written 001017, and the way we would pronounce that is tract 10.17. In our data products, the decimal point, and we're going to talk about that in a little bit, is implied 2 places to the left of the rightmost character. So there is no decimal point in the data. And the only time that decimal point is going to make any sense is you start looking at our map products, our PDF products that have the data printed. And in some of our older reports, you'll see the tract number with that decimal point in it. But in this new world of digital analysis, the tract is consistent as a 6-character field. Once again, if we divide that tract into block groups, in this case, tract 10.17 is divided twice into two block groups. The purple block group is block group 2, and we have divided that block group up into census blocks. And actually, Lacey touched on this a moment ago. The blocks are defined once every 10 years after the census tract, and block groups are defined through a cooperative program called the Participant Statistical Areas Program, and we say PSAP. Those of you who are in the emergency management might confuse it or tend to think I'm talking about the public service answering point, but the Tract program is a better way to refer to it. Really allows local governments, local planning agencies to help define the containers for the smallest level of geography, the census block, by defining census tracts and block groups. Once those are defined, we have an automated algorithm that takes the block group number and assigns a block automatically to every valid polygon within that container, which is the block group. So the tracts, the idea with the tract is that they remain the same as much as possible. That's the primary tenet of tracts. They have a target of 4,000 people. They remain the same as best as possible across decades. Within tracts are block groups, and they're given a number, and that number can change, and the boundaries within the block group boundaries can change. But once that's established, that block number is established, then all of the valid polygons within that block group are numbered automatically. And that's how we come up with the block numbers, and that's the primary reason why blocks themselves are not comparable across decades. Lacey, any comment on that?
No, I think the next one shows what this actually looks like on the ground. We had a couple of really great questions in the chat that I want to address. This question came up several times, was what are block boundaries made of? And that's a really good question. It changes throughout the country. The most common are roads. So we like a block boundary to be something that is stable over time, something that is visible, something that you can see. So it can be a railroad, it can be a stream, it can be a river, it can be a lake. Roads are obviously one. Jim, am I missing any major ones?
Political boundaries are block boundaries.
Yeah. So if there's so if a city ends, even if it's not on a something you can see or something that's not changing, we will make that a boundary simply so that we can produce data for it. So that's what our block boundaries are. There was another question, there were a couple questions about what really is a block group, and that's a really great question. Sometimes we talk about this so much we forget something that basic. A block group is literally just a group of blocks that we put together. And the reason we do that is in conjunction with local officials. We'll say, okay, inside of the census tract, are there any areas you also need data for? And they'll say, yes, within this tract, there are 3 distinct neighborhoods, and what we'll do is make each of those neighborhood block groups, but they are literally just a grouping of blocks, and they are produced with the help of local officials so that we can produce data as needed for a local area. Last but not least, and this is really interesting, Jim and I were just talking about it yesterday, and Jim, I'm going to ask you to chime in on this one. We have several people who realize that there are fewer blocks in 2020 than 2010. We have a very knowledgeable audience. Jim, do you mind touching on why there are fewer blocks this year? Because it's not really intuitive.
Sure, and that tells me we have a very astute audience.
You have a very, very impressive audience, so these are going to be good, hard questions.
Yeah, and that's a great question. I'm actually going to do a presentation on this subject at Esri this year, perhaps. I say perhaps because there's still the coronavirus. We'll see how that pans out. Into this question, when we first defined census blocks nationwide in 1990, the thought was, the more blocks, the better. The more finely granular we can be, the better detail we can have. And we kind of went that direction from 1990 into 2000 with the thought that, boy, more blocks means more data, and more data is always better, right? And those of you who have used block level data before probably started to wonder, why some of these blocks were defined in the first place, because many of them didn't make sense. Blocks, let me take a moment to try to help you understand why we define them. Ultimately, the notion of a census block is it's the smallest unit of geography for which we collect and publish data. The collect part is not exactly right, but for our definitions, when we go out and we enumerate during the census, as Lacey mentions before, we tend to walk around the block and count every housing unit and all the people within it. So that's like our fundamental piece of geography. In order to do a good count of the country, we have to cover the entire country with blocks. You can't leave gaps, right? In some places, like rural Texas and rural Colorado and rural West Virginia, the block can be quite large because the features that make up the block boundaries are spaced far apart. Well, how do we choose those block boundaries? Primarily, block boundaries are those things that make sense to be a block boundary. People live on one side of the street and on the other side of the street. They don't live in the middle of the street usually. So the street makes a good block boundary. The same thing is true with a city or with a river or a railroad. These are features that common sense tells us are a boundary between two areas. We've talked about visible features primarily, and most permanent visible features are block boundaries by default. They're part of a topological rule in our Tiger system that defines visible permanent features as being by default a block boundary. We touched on before that political boundaries and statistical boundaries are also block boundaries. And these definitions are necessary so that we can tabulate the data to not just the physical definitions on the ground, but the political and statistical definitions that we create at the Census Bureau as required by law or for programs like redistricting. So we need to be able to tabulate by whole city and be able to split areas by political boundaries. We also want to be able to tabulate data for areas that are defined by statistical geographies. So that census block then is that smallest elemental unit by which we don't publish data for anything smaller.
So just to wrap back to the why there are so many fewer this year.
I'm sorry. Thank you.
Jim gets really excited about blocks.
I do, and thanks, Lacey. I said to her,
question, I could feel it.
Yes,
and I was
that's why she's there.
I have a good example, actually, if you don't mind me jumping in here. One of the things that we fixed this year, and my block is one of the things we fixed. There are a lot of places where we had blocks because technically there was a polygon. I live on a cul-de-sac, and there is we call it a cactus circle. The cactus circle was a block. It was a circle. It was about 15 feet across, and it was full of cactuses. Cactuses? I'm not sure how you actually say that. But that cactus circle was actually a block last time. There's another road in our neighborhood that had just a median. It was just a decorative median with grass on it. And each of these medians, because they were broken up down this long street, were blocks in themselves as well. This year for 2020, we fixed a lot of that. So there were a lot of things in the past, same with highway medians. There were just a lot of things that by default were blocks, but really shouldn't have been. There was really no statistical application. And so there were a lot of blocks where there were 0 humans and 0 housing. And we were able to fix that this year with these computer algorithms. I should also mention that this is the first time that we are defining blocks by computer algorithm. In the past, we literally had human beings walking each block in the country and geocoding in that way. So that's what we're doing new this time, and that is how we eliminated some blocks that just weren't necessary and weren't useful for statistical purposes.
Thanks, Lacey. Thanks for help clearing that up.
And there are a lot of questions in the chat. I want to just mention we're going to focus on the questions that come up repeatedly. I will absolutely email you if your questions are more specific or we don't get to it. We will make sure that we respond to you in email.
Yes, thank you.
Up next, are we doing census tract splits? Is that what we're looking at?
We are doing tracts over time.
Okay, and we only have about 10 minutes, so.
Okay, let's
no
make this happen. No pressure. Why don't I let you start, Lacey? Why don't you take this slide?
Oh, great. Okay, so make one comment about the blocks, and here I am. Okay.
Here you are.
So I am a statistician. I actually didn't mention that at the beginning. But one of the best things about census tracts for me when we're analyzing data is that they are comparable over time. Now, we're going to talk in a minute about how they can change, but we still make sure that they are comparable from decade to decade. So let me back up. So in 2010, there were, New York City is actually where we started with these census tracts. There's an awesome presentation on Census Academy that specifically talks about census tracts in a lot of detail. But we started producing in some major urban areas in 1910 census tracts. By 1990, we had full coverage for the country. Now, Jim, you're going to have to remind me. So most of them were called census tracts, but then there was also an equivalent called
the block numbering area, BNA.
Okay, the block numbering area. But they were the equivalent of census tracts, and they covered the whole entire country, which was a really big deal because now we were publishing data for these, pockets of about 4,000 population nationwide. So that was a huge thing for us. Then, of course, because of growth over time, sometimes we're trying to keep this optimal level of 4,000 people in each census tract. And what we're about to walk you through is what we do when a census tract, say in 2010, had about 4,000 people. It worked out great. We published data for it. Let's say, and I know I'm using Houston a lot, but that's where there's been a lot of growth too. And let's say something that went from like cow pasture now has a major development and it has 30,000 people in it. How do we make sure that the census tracts are falling in with that criteria of population, but also make it comparable over time? We are going to talk about numbering and actually how those splits go from decade to decade. And an important note here is that the changes we make to tracts are done every decade prior to the decennial census release. So, Jim, are all of the tracts available now for 2020?
Yes, I believe they are.
That's a question that's come up several times too. Okay, and now, Jim, I'm going to turn this back over to you. This is your neighborhood.
It is.
Yeah.
Thanks, Lacey. And again, I find it very helpful to have Lacey on board to talk about geography because it really has a benefit when someone who's not a geographer looks at the geography from a different perspective. And we joke about that a lot, but I'm serious. That perspective sometimes is very important to help the data user understand the vagaries of the census geography. So let's look at an example of a single census tract in Denver, Colorado from the 2000 census. This was the old Stapleton International Airport. If you ever flew in and out of Denver before 1995, you flew in and out of Stapleton International Airport. It was like so many other airports in the country, embedded within the urban area. That wasn't the case when it was first platted in the 30s. But as the city grew up and around Stapleton Airport, you can see in this actual satellite image from the late 90s, and that explains why it's black and white. You can see that in this imagery, the runways are still there. We did cut through for the highway. The airport had just closed in this imagery about a few years earlier. It had not been redeveloped. And the population in this census tract in 1990 was 2,575 people. If we advance 10 years, we can see in this new satellite image that there's been some redevelopment for Stapleton Airport. No longer was a single tract useful for that area. In fact, a special land use tract was defined. I don't know if you can see my mouse or not. 9801 was a special land use tract defined to differentiate the commercial and industrial area from what was to become a residential area in that tract. So what was originally tract 41.05 has now been renumbered and broken into three pieces: a special land use tract, and by definition it has to have its own unique number, and two new tracts, 41.06 and 41.07, using that 6-character definition we talked about before. I'm going to rush a little bit because we're running short on time. I'm going to move forward 10 more years, and we're going to see what happens as the population continued to grow. There has been densification, redevelopment, more houses. We still have that original Special Land Use Tract 9801 because it's still a commercial manufacturing segment. Then we have several new tracts. Once again, that those tract splits with new numbers reflecting that the population has grown. They reached the maximum 8,000 persons, and so they were subdivided. In that process, in the design, we're attempting to maintain comparability to past decades by using the original boundaries. I'm going to back up one here. And if you compare the boundaries of the 2010 census tracts with those of the 2020 census, you can see that those original boundaries are still there. They've just been subdivided into smaller units, and that provides us with comparability.
And this is really important too. Jim, do you mind going back to the 2000 version?
Sure.
Something that we get a lot of questions about and can be confusing over time is, so this is the original, tract for this, well, not the original, this is the tract from 2000 for this area. And this number 004105, that number will always define this piece of land as it is in this picture. So when we go forward 10 years and we break it into, nope, you're good, and we break it into 3 different tracts, these are all different numbers. So it's not that the other one went away, so we're not going to publish data for that tract that we looked at. We're not going to be publishing data for it anymore. But that tract will always coincide only with that piece of land on the ground, right? So now we're going forward and there are new numbers. So you know that this 004107 is only going to be for that piece of land, and same with the others. And then if you go forward 10 more years, again, we're not going to continue publishing data for the tracts that we had in 2010, but these new numbers are going to stay with these pieces of land on the ground, and you can always be sure that these numbers coincide only to these, these pieces of land on the ground, these polygons.
Excellent.
Okay. All right.
Thanks, Lacey.
What else do we have going on here?
Well, I think now we were going to talk about how we store all of this information.
Awesome. And I don't know if we're going to have time for a live demo, but this is, we're getting a lot of questions on this. We're going to walk through Tiger, and then Jim, if you have about 2 or 3 minutes just to show us where these are on our website, that would be great.
Sure.
I don't know if we can. Okay.
I have that ready to roll here. So real briefly, most of you who are geographers must know about Tiger. It's an acronym for Topologically Integrated Geographic Encoding and Referencing. And Tiger really was the first national topological data set in the world. It changed not only the way the census works, but it changed the way GIS worked outside of the Bureau as well. Briefly, Tiger is a representation of what's on the ground through a series of lines, points, polygons, and areas. And that's the relationship of features in a digital system. Today we just say GIS or Geographic Information System. And Tiger is essentially a very large digital map of the country or a geographic information system. Tiger is maintained through cooperative efforts, originally built with the USGS, but now the Census Bureau has partnerships with state and local governments to maintain Tiger, its points, lines, and areas, and that's another topic for another day. But it is maintained by the Census Bureau, and we publish data from Tiger every year. And now I'm going to slide in my browser on where you can get the Tiger data. Can everyone see my browser over top there?
We sure can.
Excellent. So Tiger contains not only the linear features that the Census Bureau must have to manage its census and operations, roads, railroads, rivers, but it also has the polygons that we've discussed today, the political and administrative boundaries, and the statistical boundaries that we focused on. In order to download those for your geographic information system, you can find Tigerline shapefiles, and the easiest thing to do is just do a Google or Bing search, whatever your favorite search engine is, and search for Tigerline shapefiles. If you didn't know already, shapefile is kind of a generic term now based on ESRI's product suite. We tend to offer these Tiger files now in shapefile or geodatabase format. You can download them directly from this web page. For the existing and older Tiger Line files, there is a web interface to allow you to choose the year, the layer type that you're interested in. And if you click on it, and hopefully there we go. It allows you to choose the variety of aerial geography and linear geography for that year. We do not yet have the web interface built for the 2020 data, even though we just released it, because there's a process that we have to go to make it web-friendly. So it is available by FTP archive. So if you click on that, it's a kind of a directory-based structure, and you can navigate to their state of interest and download the latest shape files that way. And Lacey, I think that's all we have time for, unless we have some questions.
Yeah, we actually do have some questions, and I wanted to make sure that we left time for, like I said, you have a very knowledgeable audience here, so there are a lot of good questions. I want to make sure we can get to some of those. I am going to screw up the term because I always do, but Jim, what is the file that's released every decennial so that you can compare the census tracts from 2020 to, what?
Yes, this is our census tract crosswalk that we sometimes call it the crosswalk, and it's a comparability file. I don't believe that has been released yet. That requires a fair amount of processing for us to say these tracts, this tract was that tract, and so there's some relationships there that have to be established. But we do generally make that available about the same time as the redistricting data products. So I would expect very soon that comparability file will be available.
Okay, perfect. I want to mention we've had a lot of questions about other geographies that are either legal or administrative, MSAs or places, incorporated places. One of our colleagues who is a geographer as well and has worked with Jim for several years now, Dorothy McKinney, is going to do a presentation, I believe, is it May that we're planning on now to do one on those?
I don't remember.
Yeah, it's in the next couple months on those political, administrative, and legal geographies. So keep an eye out for that. However you heard about us today, it'll be the same mechanism, and we'll have that specific webinar before the decennial data is released as well. Last question I had here. There were a lot of questions about data that is published, what data is published for these different areas, and then how do you access either data from the American Community Survey or from the decennial census. We have several webinars available that are recorded on the census.gov /data/academy, which is where this is going to be posted as well. So if you want to learn how to download data for these different geographies, there's one that is specifically on finding data in data.census.gov. And that's a really great tutorial. There's actually a couple of them. It'll tell you how to pull different data from our main platform, which is data.census.gov, which is fairly new. So if you're used to FactFinder, we have a new platform, and there is a really good, there are a couple good webinars there to help you with that. I think that covers, there was one question on zip code tabulation areas. I want to touch on that. And then for everybody else who sent questions, we will absolutely get back to you via email. Zip code tabulation areas are, just a quick touch on that. Zip codes are just something that people know and love. Everybody knows what zip code they live in. A quick note on zip code tabulation areas. What we do is we use the boundaries. Actually, Jim, do you want to talk about that really like in 2 minutes, just what a zip code tabulation area is and how that basically freezes over a decade?
Sure. So obviously, the Census Bureau is not the administrator for zip codes. That's the post office. But as Lacey mentioned, there's a great deal of interest in data by zip code. So at some time in the past, I don't recall which or when, we decided we would try to create polygons that represent zip codes. We can't call them zip code polygons because they're technically not zip codes. They're actually approximations. And for that, we came up with the term zip code tabulation area. The way they were created is when we built, each decade as we build Tiger, we are able to geocode an address to a location on the ground. Anytime we geocoded an address with a given zip code at more than 50%, that entire block to which that address geocoded was assigned that zip code. So it's an approximation to zip codes which are not true topological entities. based on that algorithm. What zip code were more than 50% of the addresses in this block assigned to? And therefore, that block was assigned to that zip code. And they were aggregated together into a single polygon, and you came up with the ZICTAs. The last thing to know about them is we do not update them every year. It's something we create only for tabulating decennial data. And unless somebody had a legal or other requirement to do it more often, you'll only see an update once every 10 years after the decennial census. And I do not know when that might be available. I know we're working on it now.
Yeah, and that's a really good point. So people love zip codes. From a statistical standpoint, they can be a little tricky because they can change constantly. But we do freeze them. So we'll have create them once for a decennial census, and then they'll stay the same over the next 10 years. They're a really great data source, obviously. They're a really great geography and very useful for people, humans on the ground to understand the data they're looking at. But do just remember the zip codes can change over time, and we will have them as they were at the previous decennial. Okay, so that was a whirlwind. We will definitely get back to you with any other questions. Please check out Census Academy for other webinars on other topics, data, geography, anything else you need to know about the Census Bureau in general. And we'll have more of these coming out throughout the year, especially leading up to the 2020 decennial census release, so that you guys are ready when that data comes out. You'll have all the knowledge you need. After we wrap this up in about 30 seconds, there is going to be a survey that we hope that you guys will help us out and fill that out. Let us know how we did, what we can do better in the future. It will take you to an external site, but we would really appreciate your feedback there. And without further ado, I think that is all. Jim, is there anything else you want to say before we let everybody get back to their hopefully warmer day than mine is?
Stay warm, everyone. Thank you for attending.
Absolutely. Thank you very much.
And this concludes today's conference. Thank you for participating. You may disconnect at this time.